Hi, this is Nathan Tintle. In this Learning Goal video, we're going to talk about how to use coin tossing to simulate outcomes from a chance model. We're going to use the Can Dolphins Communicate example to motivate this discussion. Are Doris and Buzz really communicating? When Buzz pushes the correct lever 15 out of 16 times, what does that really tell us about the ability for Doris and Buzz to communicate which lever to push? What would it look like if Buzz was just guessing? Could he just be guessing and get 15 out of 16 right? Of course he could. The question is, how likely is it? In statistics, we use things called chance models to help us investigate real-world phenomena like Doris and Buzz communicating. Let's look at the parallels between a real study and this physical simulation called a chance model. See, we can use a coin flip to represent Buzz just guessing. If we want to know, well, what if Buzz was guessing? We could flip a series of coins to help us understand the kind of outcomes that are likely when Buzz is guessing. So each coin flip is going to represent a guess by Buzz. If the coin flip comes up heads, that's a correct guess. If it's tails, it's an incorrect guess. What that means then is that Buzz has a 1/2 probability or 50-50 chance of pushing the correct lever. When we do this simulation, we're going to flip a coin 16 times to represent what if we redid this study with Buzz guessing each time. So let's take a look at one set of 16 coin flips. I flipped a coin 16 times. I got 11 heads and 5 tails. So my simulated statistic is 11 out of 16, or 0.6875. This gives us a sense of the kind of thing that could have happened if Buzz had been randomly guessing which lever to push each time. So in other words, he could have been guessing and he could have gotten 11 out of 16. That's one possible outcome. It gives us a sense of the kinds of things that would happen if Buzz was just guessing. But by itself, flipping a coin 16 times isn't helpful. We really want to look at a whole series of coin flips, many sets of 16 coin flips. For this, we're going to go to the one proportion applet. On the applets page, if you click on one proportion, you'll see the following screen. What this applet allows us to do is flip many coins very fast. We'll start by just flipping one coin 16 times. We're going to leave the probability of heads at 50%, representing what if Buzz was just guessing. We're going to set the number of tosses to 16, and we're going to toss those coins. You'll see now this coin being flipped 16 times. Once the 16 coin flips finish, we'll see down here at the bottom of the screen the number of heads and the number of tails, and then a dot right here in the middle on the dot plot of the number of heads we got this time, 9. So 9 is the kind of thing that could happen if Buzz is just guessing. But again, we want to get a sense of all the kinds of things that could happen if Buzz was just guessing and just how likely they are. For this, we're going to do many more repetitions. So I'm going to turn animation off and toss another set of 16 coins. What you'll see happen is another dot will show up on the dot plot. Now we have 10 heads out of 16. Every time I click the Toss Coins button, I've flipped another set of 16 coins, this time getting 6 heads. As I toss more and more sets of 16 coins, I begin to get a sense of the kinds of things that happen if Buzz is just guessing. I've done 50 sets of 16 coin flips now. I have 50 dots on the dot plot. And I'm beginning to see that numbers like 7, 8, 9, and 10 are quite common. Numbers bigger than 14 and less than 4 are less common. I can increase the number of repetitions. I'll add 950 more to get a set of 1,000 coin flips, 1,000 sets of 16 coin flips. And I get a nice picture of the kinds of things that happen if Buzz is just guessing. Now, seeing that numbers between about 5 and 12 are quite likely, numbers 13 or greater, 4 or less are quite unlikely. A few words of caution. Coin flipping only works if the variable has 2 equally likely outcomes. In other sections of the textbook, we'll see situations where that's not the case. A repetition is a set of flips that's equal to the sample size in the study. So in the Doris and Buzz example, a repetition is a set of 16 coin flips because Buzz pushed the lever 16 times. The last word of caution is this. You really need many repetitions of the coin flipping chance model to understand long-run behavior. We can't just merely flip a coin 16 times. That gives us one potential outcome from the Doris and Buzz study if Buzz is just guessing. We really want to get a sense of many, many repetitions to give us a picture of which outcomes are more or less likely.